Chandrayaan-3 is a hypothetical lunar mission that was proposed by the Indian Space Research Organization, ISRO, as a follow-up to their Chandrayaan-2 mission. Chandrayaan-2 was launched in July 2019 and included an orbiter, a lander named Vikram, and a rover named Pragyan. While the orbiter successfully continues its operations, the lander failed to make a soft landing on the moon's surface. Chandrayaan-3, if it were to become an actual mission, would likely be designed to address the goals that were not achieved by Chandrayaan-2's lander and rover. This would involve attempting another soft landing on the moon's surface and deploying a rover for scientific exploration. There wasn't any additional specific information available about Chandrayaan-3 beyond what I've already provided. The mission was still in the proposal stage, and no concrete details had been officially released by ISRO at that time. For the most accurate and up-to-date information about Chandrayaan-3, I recommend visiting the official website of the Indian Space Research Organization, ISRO, or referring to reputable news sources related to space exploration. There might have been developments or announcements about Chandrayaan-3 since then that I'm not aware of. As of my last update, ISRO had expressed interest in planning Chandrayaan-3, but no official mission details, launch dates, or finalized plans had been announced. Please refer to official ISRO sources or recent news updates for the most current information on the Chandrayaan-3 mission, as developments may have occurred after my last update. While I don't have specific information about Chandrayaan-3, I can provide you with a general overview of how lunar missions like Chandrayaan-3 typically work based on previous lunar missions, including Chandrayaan-1 and Chandrayaan-2. 1. Launch. Risk. The mission begins with the launch of the spacecraft from Earth using a suitable rocket. The spacecraft is designed to carry the necessary instruments and components to perform its mission objectives. 2. Translunar injection. TLI. After reaching a specific orbit around Earth, the spacecraft performs a maneuver called translunar injection, which propels it out of Earth's orbit and onto a trajectory toward the Moon. 3. Lunar orbit insertion, LOI. Upon reaching the Moon, the spacecraft performs another critical maneuver to slow down and enter lunar orbit. This allows the spacecraft to establish a stable orbit around the Moon. 4. Orbital mapping and analysis. Once in lunar orbit, the spacecraft's instruments start mapping and analyzing the lunar surface. This data helps scientists understand the Moon's topography, mineral composition, and other characteristics. 5. Landing, if applicable. If the mission includes a lander and rover, as in Chandrayaan-2, a lander carrying the rover is detached from the orbiter. The lander then enters the Moon's atmosphere and performs a controlled descent to the lunar surface. 6. Rover deployment. Once safely on the lunar surface, the lander deploys the rover. The rover is equipped with various scientific instruments to study the Moon's surface, analyze soil samples, measure temperature, and gather other data. 7. Data transmission. The orbiter and rover are designed to transmit data back to Earth. This data includes images, measurements, and scientific observations collected from the lunar environment. 8. Scientific research. The data collected by the orbiter and rover are analyzed by scientists and researchers to gain insights into the Moon's geological history, its surface characteristics, and other relevant scientific information. 9. Asterisk mission duration. The mission's duration varies based on its objectives and design. Some missions are designed to last a few weeks or months, while others, like the Chandrayaan-1 orbiter, can continue to operate and transmit data for years. 10. Asterisk mission end. The mission may end when the spacecraft's systems degrade due to the harsh lunar environment, lack of power, or other factors. In some cases, the spacecraft might be intentionally directed to impact the Moon's surface at the end of its mission. It's important to note that the specifics of Chandrayaan-3's design and operation, if it has been developed since my last update, would depend on the mission's objectives and technological advancements. For the most accurate and current information about Chandrayaan-3, I recommend checking official ISRO sources or recent news updates related to the mission.